Hello, everyone. I'm Ariel Goldman. I'm a senior at Barnard College, and today I'm going to talk about using deep learning to assist affinity diagramming, a type of qualitative data analysis. One key method for producing nuanced interpretations of qualitative data, affinity diagramming, is ideal for wide-ranging unstructured data. In this method, raw data, such as responses to interview questions and observations, are iteratively grouped from the bottom up, forming a hierarchy that facilitates understanding the data. This process of affinity diagramming is relatively fast compared to methods such as qualitative coding. However, for large data sets, the diagramming process is inefficient and overwhelming. While a smaller diagram may take a few hours to build, larger diagrams can take multiple days. Due to this limitation, researchers may avoid affinity diagramming if their data set is large, causing them to miss out on nuanced data interpretations affinity diagramming can provide. QuAD assists in the affinity diagramming process by providing pre-grouping suggestions for similar notes and by providing a digital layout conducive to large diagrams. The first step of grouping is to determine how similar the data are to each other. We do this using BERT, which stands for Bidirectional Encoder Representations from Transformers. Then, utilizing our knowledge of how similar any two notes are to each other, we construct a graph, with each note being a node and each edge weight being their similarity. We then apply the Girvan-Newman algorithm, which breaks our notes into clusters of related data. These clusters are the groups of notes we then present to the users as grouping suggestions. Here are a few example groups made by QuAD from a dataset of students discussing things they learned. The groupings on the left have a clear connection to one another, which are shown in the human-generated labels for these groups. It's likely a user would accept these groupings for use in the diagram. The grouping in the middle is likely to be edited before it is accepted, since the first three nodes are all connected to one another, but the fourth node is not. The groupings on the right are likely to be rejected by the user, since the notes in each group do not have a clear connection to one another. These examples hopefully illustrate that while it's important humans have the final say in the diagramming process, QuAD's pre-grouping suggestions would be a useful tool for diagrammers to help speed up their process. QuAD also assists users by providing a user interface conducive to large affinity diagrams. The interface uses a shared vertical screen and an individual tablet for each collaborator. The vertical screen, seen on the left, allows the diagrammers to get a view of the entire diagram while it's being created and to see where each collaborator is currently working on the diagram. The interface is designed to help users keep things organized and manageable when they are working on large data sets. In summary, QuAD utilizes natural language processing and graph clustering to provide grouping suggestions to affinity diagrammers. It also provides a user interface designed to facilitate an easy diagramming process with large data sets. The hope is that QuAD, through these features, will make affinity diagramming more efficient and feasible for larger data sets. Thank you all for listening.